Welcome back from the ad break, and let's continue with our lesson. So now we are going to be going into that first concept in our concept map, and that is representation of geometric patterns in tables and algebraically. Let's look at the following geometric pattern that we have been given here. So we have been given 4 figures here. So we have the first figure, the second figure, the third figure, and the fourth figure. Now these figures form a geometric pattern. Now we have to see what that pattern is. So in the first figure we have 1 block. In the second figure we have 4 blocks. In the third figure, we have 9 blocks, and in the fourth figure, we have 16 blocks. So that is the pattern that is formed there. So how many blocks will be in figure 5? So looking at this pattern, 1, 4, 9, and 16, have you seen how this pattern is moving? Do you know how many blocks are going to be in figure 5? Well, if you are thinking of 25, then you are correct. How about how many blocks are going to be there in figure 6? Well, if you found the number of blocks in figure 5, you already now have seen the pattern and you know what it is for figure 6. Do you have an answer of 36? Then yes, you are correct. What about the 7th figure? How many do we have there? Yes, it is 49. So how would you explain this pattern in words? Now, you have already seen this pattern. That's why you were able to get the number of blocks in these figures. But let's look at how it is. So in the first figure, there was only 1 block. And in the second figure, there are 4 blocks. What is the relationship between the term number and the term itself, or the figure itself? Well, yes, 1 is equals to 1 squared, and 4 is equals to 2 squared, while 9 is equals to 3 squared. Do we see the pattern that is going on with these blocks, or this geometric pattern? Of course, in the fourth figure, we had 16, which is 4 squared. So how can we explain the pattern in words? It is taking the term number and we are squaring it. So we can say that we are squaring the term number. Let's see how we would now represent this algebraically. So let's look at those blocks again, and we've already found that sequence which we have seen is 1, 4, 9, and it continues right up until there. Let's fill out that table first before we can represent it algebraically. So we saw that the first term was 1, second term is 4, third term is 9, fourth term was 16, then the next term was 25, next term was 36, and the next term is 49. So that was quite simple there, filling out that table. Now this table needs to help us in finding an algebraic representation of this sequence or of this geometric pattern, because as we know that the first term, what is going to be in the second term, and it was quite easy to find the next term as well. But what about the 12th term? Again, we need to find that relationship between the term number and the term. So let's find that 12th term. So what would the rule be for this pattern in order for us to find that 12th term? Well, we've already spoken of the rule, and the rule is us now squaring the term number. So we are just going to square that term number. That means that if we represent our rule algebraically, this is Tn is equals to n squared. So if we are looking for the 12th term, which is T12, That means we are going to take our rule and we are going to substitute. So what are we going to substitute? Well, in the place of n, we are going to place there a 12. And of course, what will our answer be from saying 12 squared? We know 12 squared is 12 times 12, which is going to give us 144. So in this pattern, the 12th figure is going to have 144 blocks. Let's move over to the next pattern here. So we again have been given a geometric pattern, and this pattern is now formed of triangles. So we have 3 figures there. Now we have the first figure that has 1 triangle. We have the next figure that has 3 triangles. So that is 1 and 2 and 3. And we have the next figure that has 5 triangles. So that is 1, 2, 3, 4, and 5. So how many triangles are going to be in the 4th figure? Yes, you are correct. It will be 7. And how many triangles will be in the 5th figure? Yes, it is going to be 9 triangles. I am sure that by now you have seen the pattern. How many triangles are going to be in the 6th figure? Yes, you are correct. It will be 11 triangles. So let's explain the pattern in words. What is happening each time we move onto each figure? Yes, we are adding 2 triangles to the previous figure. So we are just adding 2 triangles to the previous figure. So let's see or represent this geometric pattern in our table. So we've already found the first 6 terms, so we are just going to represent them in our table, and that is going to be 1 and 3 and 5, 7, 9 and 11. And remember, those come from our figure there above, or our figures there above. Now, how would we find the 20th term? So this table is supposed to help us to come up with a geometric pattern algebraically so that we can be able to represent any number or any figure, so that when you are asked any figure, you would know how many triangles that figure would have. So right now, how would we find the 20th term or the 20th figure? Firstly, the relationship between the term number and the term. So looking at this figure again, we know that this is the first figure, the second figure, and the third figure. And we know that the number of triangles there, this first one has 1 triangle, the second one has 2 triangles. And so the first one has 1 triangle, the second diagram has 3 triangles, and the third diagram has 5 triangles, as represented there with our numbers. Of course, the 4th figure would have their 7 triangles. Now, how are we going to find the 20th term? Of course, we have to find our rule. So our rule is going to be represented by Tn. And since as well we know how we are moving from the first figure to the second figure, we saw that we are adding a constant number of triangles, which is our 2, which is also our constant difference. So we are adding 2 every time we go to the next figure. So this is going to be now our term number or our figure number, and that is also represented by n. That is going to be multiplied by 2. So that is going to be the constant difference of 2 multiplied by our figure number or our term number, and we are going to add or subtract a constant value. So we are going to test that with the first figure. Now the first figure only has 1 triangle. So remember, we are going to say the constant difference of 2 multiplied by the 1 add or subtract something so that we can get to our 1. So 2 multiplied by 1 is 2, and then we are going to subtract 1 to get to 1. What about the fourth figure? So the fourth figure, even though it's not shown here, we know will have 7 triangles there. So this is going to be 2 multiplied by 4 because we are working with the fourth figure or the fourth term. Then we need to add or subtract a constant so that we get to 7. Now 2 multiplied by 4 is 8, and we can simply subtract 1 so that we get to that 7. So what is our rule here? Our rule is going to be 2 multiplied by the term number minus our 1. Now that rule is the one that's going to help us with calculating our 20th term. Now our 20th term here is going to be 2 multiplied by our 20, and when we subtract 1, then we are going to get an answer of, do you have it already? Yes, it is 39, because 2 multiplied by 20 is 40, and then when we subtract 1, we get an answer of 39. Let's quickly go to an ad break, and then we'll see you just now.